Time is something we always seem to have in abundance and yet are always running out of. But what is time, really? This question has puzzled philosophers and scientists for centuries, and the answers are as complex as they are fascinating. From Aristotle, who believed time was nothing more than the measure of change, to Newton, who saw time as an absolute entity, our understanding has evolved dramatically. In ancient civilizations, time was often tied to celestial events, like the cycles of the moon or the seasons. But as our understanding of the universe grew, so did the need for more precise timekeeping. The invention of the pendulum clock in the 17th century by Christian Huygens was a monumental leap. It allowed humans to measure time with unprecedented accuracy, ticking away every second like a heartbeat of the cosmos. As we moved into the 20th century, a revolutionary shift occurred with Einstein's theory of relativity. His groundbreaking ideas suggested that time is not a constant but a variable, flexible and relative, dependent on speed and gravity. Imagine being on a spaceship traveling close to the speed of light. Time would slow down for you compared to those on Earth. This concept of time dilation challenged our traditional perceptions of time, introducing us to a universe that's not only stranger than we imagine, but stranger than we can imagine. We must also consider time from a more subjective angle. How our experience of time changes with age, culture, or even mental state is a deeply psychological aspect of understanding time. For instance, time seems to speed up as we age. This phenomenon is often attributed to the number of new experiences we accumulate. Less novelty can lead to the perception of time passing more quickly. But there's also cultural time, where different societies perceive time in varied ways. Some see it as linear, while others may view it as cyclic. We will explore these different perceptions and their implications throughout this documentary. Thus, to ask what time is to venture into a realm that intersects the philosophical, the scientific, and the deeply personal. As we continue on this journey, keep this question in mind: if time is an illusion, what does that mean for our everyday lives? As we unravel these complex views and theories about time, prepare for a ride through the dimensions of reality that will reveal astonishing truths about the essence of existence itself. As we continue our exploration, let's dive into the evolution of timekeeping. Imagine a time when humans had no concept of minutes or hours. How did we transition from sundials and water clocks to atomic precision? Ancient civilizations tried various methods to measure time. The Egyptians used sundials, the Greeks relied on clepsydras, or water clocks, while the Chinese innovated with their own mechanical devices. These early attempts were rudimentary, yet they laid the groundwork for our understanding of time measurement. The first mechanical clocks appeared in Europe in the late Middle Ages. These were often large, unwieldy structures found in town squares. As technology progressed, so did our ability to keep time accurately. By the 17th century, Galileo's pendulum theory was the catalyst for a revolution in timekeeping. Huygens, inspired by this, developed the first true pendulum clock, boasting accuracy unheard of before this time. But it wasn't until the 19th century that timekeeping truly transformed. With the advent of the Industrial Revolution, the need for synchronization grew as trains and factories operated on stringent schedules. This led to the establishment of standardized time zones. In 1884, at the International Meridian Conference, the world was divided into 24 time zones, establishing Greenwich Mean Time as the prime basis for timekeeping worldwide. By the 20th century, the invention of the quartz clock marked another leap. Quartz crystals vibrate at a consistent frequency, allowing for more precise timekeeping than ever before. Then, in the 1950s, atomic clocks emerged, utilizing vibrations of atoms to measure time with extraordinary precision. These devices are so accurate they can lose just 1 second in millions of years. Now, we are experiencing yet another revolution with optical lattice clocks. These fascinating instruments trap atoms in a grid of laser light, achieving even greater accuracy than atomic clocks. Researchers report that these clocks could redefine the second itself, impacting everything from GPS technology to fundamental physics. The history of timekeeping is not just about the tools we use, it's also about the cultural shifts that accompany these advances. Think of how time dictates modern life, from work schedules to our internal biological clocks. This intricate relationship has evolved hand in hand with our scientific advancements. As we wrap up this chapter on the evolution of timekeeping, consider how these measures of time have shaped your daily life. Are you living by the clock, or do you find ways to escape its confines? With this question in mind, let's step into the next chapter, where we will examine Einstein's revolutionary theories that changed everything we thought we knew about time. In the realm of physics, Albert Einstein's ideas about time sent shockwaves through our understanding of the universe. His theory of relativity altered everything, reshaping our ideas from static notions of time to flexible and dynamic perspectives. Einstein's special relativity, published in 1905, introduced a radical idea: time and space are interconnected. A key aspect of this theory is the concept that time is relative. First, consider the famous thought experiment involving twin astronauts. One twin travels to a distant star at near light speed while the other remains on Earth. Upon returning, the traveling twin would be younger than the one who stayed behind. This is not science fiction, it's a real consequence of time dilation as predicted by Einstein's equations. Einstein later expanded these ideas in his general theory of relativity, which he published in 1915. This theory introduced the idea that gravity could affect time itself. Near a massive object like Earth, time moves slower than it does in space. This phenomenon has been confirmed through experiments, such as those conducted with atomic clocks placed at various elevations. But Einstein wasn't just a physicist, he was also a philosopher. He once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." This statement invites us to ponder whether time is merely a construct of the human mind, a way to organize our experiences within the universe. Consider how time equations can also lead to the concept of time travel. According to the equations of general relativity, if we could create a wormhole, a theoretical passage through space-time, it might be possible to travel backward and forward in time. However, the implications of time travel lead us into paradoxical situations. The famous grandfather paradox suggests that if one were to go back in time and prevent their grandfather from meeting their grandmother, would they cease to exist? Such paradoxes illustrate the complexities of time and our understanding of it. As we grasp these principles, it's critical to understand how they are not just idle theories, they hold profound implications for our understanding of the universe. For instance, GPS technology relies on these very principles of relativity. The satellites that enable GPS need to account for time dilation due to their speed and position in Earth's gravitational field. Thus, Einstein's theories bridge the tangible world of technology with profound philosophical questions. As we conclude this chapter, think about the implications of time being both an illusion and a reality that shapes every moment of our lives. This concept leads us seamlessly into our next chapter, where we will unravel the biological aspects of time, exploring how time affects our very existence. What if I told you that time doesn't just exist in the universe but also within us? The relationship between time and biology is an intricate dance, where our body's rhythms are intimately tuned to the passage of time. An essential aspect of this relationship is our circadian rhythm, the internal clock that regulates our sleep-wake cycles and numerous physiological processes. This approximately 24-hour cycle is driven by an array of biological mechanisms, including genes and various hormones, that pulse in sync with the Earth's rotation. When we sleep, our body goes through different stages, and these stages are regulated by our circadian rhythm. Sleep, in turn, affects how we perceive time. Those who are sleep-deprived often report a distorted experience of time, feeling as if hours stretch into eternity. Conversely, when we are fully rested, time flies by. Researchers have found that this illusion of time passing can also change with age. For children, every new experience seems to expand time, while adults often feel as if time shrinks as they settle into routines. Moreover, our biological clocks can be disrupted by external factors, including artificial light and lifestyle choices. This disruption can have significant implications for our health. Studies suggest that irregular sleep patterns can lead to higher risks of cardiovascular diseases, obesity, and mental health issues. In understanding how time impacts our biology, we must also acknowledge the concept of time perception. This is particularly fascinating in psychology, where experiments show that our perception of time can be influenced by the situation we are in. For instance, a thrilling experience can make time feel like it's flying, while dull moments drag on infinitely. The effects of time on our biology extend even further. Consider how aging impacts our perception and physiological experience of time. As we get older, our brains can slow down processing speed, leading to the feeling of time speeding up as we age. On a deeper level, the biological concept of time leads us to question the nature of existence itself. Are we mere passengers on a train called time, or do we wield some influence over how we experience it? As we wrap up this chapter on the biological aspects of time, let these concepts simmer in your mind. How does your own experience of time shape your life? How can understanding these rhythms lead to more meaningful experiences? As we delve into our next chapter, we will explore the fascinating realm of time perception and how our minds construct the passage of time. As we delve into the perception of time, we step into a realm that is as subjective as it is universal. How do our brains interpret time, and what factors influence our experience? This is a question that has captivated scientists, philosophers, and artists alike for centuries. The brain does not have a dedicated time center. Instead, various regions work together to help us perceive time. Studies show that our perception is heavily influenced by external cues, such as the environment and our emotional state. For example, when we are engaged or excited, time seems to fly by. In stark contrast, moments of boredom can stretch eternally. One intriguing phenomenon related to time perception is the oddball effect. When we experience something unusual or novel, our brains mark it as significant, creating a richer memory. This richness makes time seem longer in retrospect. Cultural factors also significantly influence how we perceive time. In some cultures, time is viewed linearly, while in others, it is seen as cyclical. This cultural backdrop influences how an individual values punctuality, planning, and even leisure. Moreover, age plays an undeniable role in time perception. As we grow older, memories and experiences become fewer, and time tends to feel as if it moves faster. Researchers suggest that the frequency of new experiences is crucial in shaping our perception of time. That's why childhood, filled with novel experiences, can feel prolonged compared to adult life, which often falls into routine. Interestingly, experiments in psychology reveal that when our attention is focused on the passage of time, like when we're waiting for something, it seems to creep along. Conversely, when we're engrossed in activities, time flies. This phenomenon highlights how our consciousness constructs our experience of time, making it deeply individual and variable. In summation, the perception of time is a rich tapestry woven from our biology, culture, emotional state, and a myriad of external cues. As we conclude this chapter, consider the next time you feel time slipping away or dragging. Ask yourself, how much of it is truly experienced, and how much is a construct of your mind? In our next chapter, we will explore more extraordinary theories and practices surrounding the concept of time, including the intriguing idea of time travel. Imagine a world where time itself is not constant, a world where your perception of time could stretch and compress like elastic. This is the remarkable essence of time dilation, a phenomenon predicted by Einstein's theory of relativity that has mind-blowing implications. It's not fiction, it's physics, and it reshapes our understanding of the universe. To illustrate time dilation, let's consider a real-world scenario involving high-speed travel. When astronauts journey into space, they experience less passage of time compared to their counterparts on Earth. This effect has been confirmed through experiments with atomic clocks aboard fast-moving aircraft. For instance, a clock flown around the world on a jet lags behind stationary clocks, proving that speed can literally slow down time. As we delve deeper, we find that time dilation isn't just confined to the vastness of space. It also applies on smaller scales. A classic example is GPS satellites. They orbit the Earth at such high speeds that their onboard clocks tick slightly faster than those on the ground. To maintain the precision of location tracking, these clocks are adjusted to account for time dilation, ensuring the technology we rely on is accurate. This fascinating twist brings us to gravitational time dilation, another aspect of Einstein's theory. Here, time moves slower in stronger gravitational fields. Consider the clocks on a mountain versus those at sea level. The difference is measurable, even if minute. As scientists study black holes, they discover that as objects approach this dense gravitational pull, time effectively halts relative to an outside observer. Perhaps that's why black holes hold such an alluring mystery in the cosmos. Astrophysicists utilize these principles of time dilation in their ongoing quest to understand the universe. As we probe deeper into dimensions and the fabric of space-time, we're left contemplating how these mind-bending concepts affect our everyday experiences. What does it mean for our understanding of life, death, and the universe around us that time isn't a constant? The implications of time dilation stretch beyond science, influencing philosophy and existential thought. How do we perceive our lives in this context? If time is elastic, how do we feel its passage in our daily lives? The layers of intrigue continue to unfold, leading us into the next chapter where we explore time's intertwined relationship with technology and its role in reshaping our future. As we journey forward, can we manipulate time in ways that seem only imaginable? Prepare to find out. In our modern world, time is a crucial element driving every aspect of our lives. From the moment we wake up until we go to bed, technology governs our perception of time. But how did we reach this juncture, where technology becomes the arbiter of our daily activities? Let's take a step back in history. The advent of mechanical clocks in the 14th century marked a significant turning point in how humanity understood and controlled time. These intricate devices began to dictate schedules and routines. As trade and commerce expanded, accurate timekeeping became necessary and valuable. One fascinating case is the establishment of the Greenwich Mean Time in the 19th century, which provided a standardized time reference for the global community. Fast forward to today, and we witness the evolution of technology that has further refined our timekeeping abilities. Atomic clocks, based on the vibrations of atoms, are now the gold standard. These marvels are precise to within a billionth of a second. When we consider the coordination of global positioning systems and telecommunications, atomic clocks are indispensable. However, this raises challenging questions. Does our reliance on technology to measure time undermine our intrinsic relationship with it? As we become slaves to punctuality, is there a risk of losing our natural sense of time? The cultural implications are profound. In some societies, the clock rules daily life, while others embrace a more fluid relationship with time. Moreover, the rise of digital technology, particularly smartphones, has altered our perceptions of time even further. Notifications, alerts, and the constant stream of information keep us tethered to the present moment. But at what cost? The phenomenon of time poverty arises when the demands of technology stretch our time thin, leaving us feeling rushed and overwhelmed. As we consider the effects of technology on our relationship with time, we're led to ponder, can we balance the benefits of technological advancement with the need for a deeper connection to time? With each tick of the clock, we approach an era where technology could not only dictate time but potentially redefine it. Join us as we delve into the next chapter, exploring the philosophical implications of time travel and whether it might be more than just science fiction. The concept of time travel has captivated humanity for generations. From novels to blockbuster movies, the allure of traversing the past or leaping into the future stirs our imagination. But is it possible? First, let's examine the framework laid by physics. Einstein's theory of relativity opened the door to time travel possibilities. The idea that massive objects could warp space-time raises questions. Could we, in theory, manipulate these fluctuations to navigate through time? One theoretical method is through wormholes, tunnels through the fabric of space-time. These could connect distant points in time and space, allowing for instantaneous travel. However, the reality is far more complex. The existence of stable, traversable wormholes remains purely speculative. Another approach is through the concept of light speed. According to relativity, as objects approach the speed of light, time dilation occurs. This means that if we could travel at such speeds, we could potentially leap into the future. Nonetheless, paradoxes arise. The grandfather paradox, for instance, poses a significant philosophical dilemma. What happens if you travel back in time and prevent your grandparents from meeting? Would you still exist? Such paradoxes lead us into a labyrinth of theoretical thinking where causality and free will are persistently challenged. Despite these challenges, scientists continue to explore the universe's mysteries. Researchers like Kip Thorne theorize on the possibilities of time travel, fueling discussions about quantum mechanics and the potential for paradox-free timelines. Yet, time travel remains in the realm of theory, with no practical means of achieving it as of now. As we ponder the implications of time travel, we begin to grapple with profound philosophical questions. If given the chance, would we want to change the past? Would we dare to know our futures? The mysteries of time beckon us, and with every inquiry, we inch closer to unraveling its secrets. What awaits us in the final chapters of this journey? The exploration of how time influences our psyche and shapes our future is just around the corner. Our journey through time has been scientific, philosophical, and now we arrive at the psychological dimensions of time. How do we, as humans, perceive time? Is it a linear progression, or do we experience moments in a more fragmented manner? Consider how the perception of time can vary dramatically based on our activities and emotions. When we are engaged in joyful activities, time often seems to fly by. Conversely, during periods of distress or boredom, each second can feel agonizingly prolonged. This subjective experience of time is influenced by numerous factors, including age, attention, and emotional state. Psychologists have explored the relationship between age and time perception. Children, for instance, may perceive time as moving slowly due to their lack of lived experiences. As we grow older, time appears to speed up, perhaps because each year becomes a smaller fraction of our life. This phenomenon has profound implications for how we live our lives. It suggests a need to savor moments and create lasting memories. Moreover, our culture impacts our perception of time. In a fast-paced society, where efficiency reigns supreme, time is often treated as a commodity. On the other hand, cultures that embrace a more laid-back approach often report a richer experience of time. Finding balance is key. How can we manage our busy schedules while also engaging in experiences that enrich our perception of time? The psychological implications of time can also surface in mental health. Those struggling with anxiety might find themselves fixated on the future, while individuals with depression can become trapped in a cycle of ruminating about the past. Understanding this relationship offers insights into therapeutic practices that help clients reclaim their time and manage their mental well-being. As we explore the psychological aspects of time, we position ourselves for the next crucial chapter, contemplating the future of time itself in a rapidly evolving world. What advancements lie ahead? Can we redefine our relationship with time as technology evolves? Stay tuned as we uncover the potential future of time in the final chapter. As we stand at the crossroads of science, technology, and philosophy, what does the future hold for our understanding and experience of time? The rapid pace of technological advancement invites both excitement and trepidation as we consider the implications for our daily lives and the cosmic narrative. Recent advancements in quantum computing, AI, and even neuroscience are reshaping our relationship with time. Imagine a world where technologies can potentially enhance our perception, allowing us to savor moments or compress time during routine tasks. The possibility of simulating experiences in virtual environments fully could transform our capacity to interact with time itself. As we embrace such advancements, ethical considerations emerge. With AI capable of managing our schedules and time resources, will we risk becoming overly reliant on technology? As we journey through the digital age, we must ask ourselves, how do we want to interact with time in this future world? Moreover, as we expand our reach into the cosmos, the quest for understanding time may take on new dimensions. Space exploration could provide insights into time's nature, possibly unveiling its malleability in ways we haven't yet imagined. Just imagine the possibility of discovering time anomalies that change our understanding of physics. In a world constantly racing against time, how do we cultivate mindfulness and presence? Initiatives promoting mental well-being encourage individuals to step out of the vicious cycle of productivity and rehearse moments of pause. By marrying technological advances with mindful practices, we can harness time's true potential. As we conclude this exploration, we're left with a profound realization: time is not merely a measurement, it is a deep and complex tapestry that weaves through all aspects of existence. Whether we perceive it as a constant or an enigmatic force, how we engage with it will define our human experience in the future. As we move forward, let us remain curious and open, for time may hold secrets yet to be unveiled. The influence of time will forever resonate through our understanding of life, urging us to explore its depths and embrace every moment as it comes. The journey through time continues, inviting us to question, explore, and discover. Time is not just a mere measuring stick for events, it plays a critical role in the universe's fabric. Without time, the very theories of physics would collapse into chaos. To understand how intertwined time is with space, we must delve into the concept of spacetime. Albert Einstein introduced us to this beautiful concept that combines time with the three dimensions of space, suggesting they are inseparably linked. Up until his theory of relativity, time was treated as an independent entity, a constant that ticked away regardless of anything else occurring in the universe. But Einstein challenged that viewpoint. In his landmark work, he proposed that time is affected by gravity and velocity. An example of this can be found in a thought experiment where we imagine two twins, one traveling at the speed of light while the other remains on Earth. According to Einstein's theory, the traveling twin would age slower due to the concept of time dilation. This has profound implications for our understanding of time. In fact, scientists have demonstrated this phenomenon using atomic clocks placed at different altitudes. Clocks on satellites orbiting Earth experience slightly different passage of time compared to those on the ground due to gravitational time dilation. Additionally, the universe itself is expanding. This fact is also linked to the concept of time. As the universe grows, distances between galaxies increase. This expansion means that time, rather than being static, is enshrined in a dynamic framework that is constantly changing. Scientists have observed the rate of this expansion through redshift, a phenomenon that essentially captures how light stretches as galaxies move away from us. The farther a galaxy is, the faster it seems to be moving away, leading to the conclusion that time and space are dynamically woven together in the universe. Moreover, cosmologists look at the cosmic microwave background radiation as a remnant from the early universe, providing a snapshot of time shortly after the Big Bang. This ancient light tells us a compelling story of the universe's infancy and the evolution of time itself since that monumental event. Understanding the role of time in the cosmos opens up captivating questions about existence itself. What does it mean for our understanding of the universe? As we explore this vast fabric of time and space, we uncover the complexity of our reality, suggesting that time is not merely something we measure but also something that shapes the universe at its core. As we finish our exploration of the role of time in the universe's fabric, we might wonder, is time a fundamental aspect of the universe, or is it merely an illusion constructed by our minds? The question lingers, enticing us to delve deeper into the mysteries of time and existence as we proceed to our next chapter. Throughout history, cultures around the world have perceived and treated time in profoundly different ways. To grasp the essence of time, it's imperative to understand these cultural perspectives. For instance, in Western cultures, time is often viewed as linear, a straight path from past to future. This perspective aligns with our Gregorian calendar and is reflected in how we structure our lives around schedules and deadlines. However, in many Eastern philosophies, time is often seen as cyclical. In Hinduism and Buddhism, for instance, time is viewed as a series of cycles, bound to the concepts of reincarnation and karma. This cyclical nature of time can evoke a sense of eternity, as life and death continuously flow into one another. Consider the concept of Kalachakra in Buddhism, which translates to Wheel of Time. This intricate framework illustrates how time is a continuous cycle of birth, existence, and dissolution. This contrasts sharply with the Western emphasis on productivity and progress, often paving the way to stress and anxiety in modern society. One could argue that an endless rush to achieve future milestones detracts from living fully in the present moment, a lesson that many Eastern traditions emphasize. In many indigenous cultures, time is viewed as an interconnected web, where past, present, and future coalesce. Native American tribes, for example, often refer to the concept of being in the moment, suggesting a deep awareness of their ancestral heritage while being grounded in the present. The land itself carries stories of the past, merging with the present to inform future generations. Similar to this, African cultures often possess a rich tapestry of oral traditions that bind time through storytelling, where the past remains alive and influential. Interestingly, the globalized nature of modern society has led to a blending of these temporal perspectives. In urban centers worldwide, you'll find a mashup of strict schedules next to leisurely siestas, with people often grappling to find a balance between productivity and mindfulness. Technology further complicates this relationship, with time zones, digital clocks, and instant communication reshaping how we experience time in our daily lives. Social media, a modern phenomenon, allows us to experience events in real time, compressing our sense of time into perpetual immediacy. Yet, this constant connectivity also invites a feeling of being overwhelmed, blurring the lines of what it means to live in the moment. Ultimately, understanding cultural perspectives on time reveals a great deal about human experience. Are we mere victims of the clocks that bind us, or can we learn to navigate our temporal experiences in a way that honors both the past and the present? As we ponder this question, let's move forward to explore the impact of time on societal structures. The concept of time travel has fascinated humanity for centuries, capturing our imagination through literature, film, and scientific inquiry. What if we could traverse the very fabric of time itself? While many have dismissed time travel as mere science fiction, physicists have pondered its feasibility based on the principles of relativity. At the heart of time travel lies the theory of wormholes, hypothetical passages through spacetime that could create shortcuts between two distant points. If these wormholes exist, they could, in theory, allow us to travel back and forth in time. However, the concept of time travel raises complex paradoxes, particularly the infamous grandfather paradox. This thought experiment suggests that if someone were to travel back in time and prevent their grandfather from meeting their grandmother, it would create a contradiction. How could the time traveler exist in the first place? This paradox has sparked ongoing debates among physicists, philosophers, and storytellers alike. Such discussions delve into the implications of causality and free will, highlighting how intertwined our understanding of time is with human consciousness. Moreover, recent research has explored the idea of closed time-like curves. These theoretical constructs propose a method for traveling back in time without the typical paradoxes associated with time travel. In these scenarios, one could traverse back to a point in time without necessarily altering past events, as the timeline is self-consistent. Yet, critics argue that even if these theories hold, practical time travel would require vast amounts of energy and advanced technology far beyond our current capabilities. In addition, some physicists propose the existence of alternate dimensions or parallel universes. If many worlds exist simultaneously, it might be possible to travel back to a different version of reality rather than altering our original timeline. This idea evokes tantalizing possibilities, opening doors to infinite narratives where different choices create divergent realities. However, these scientific assertions are still speculative and heavily debated within the scientific community. As we contemplate the reality of time travel, we are confronted with a host of ethical implications and philosophical questions. Would we, as a species, be responsible enough to handle the power of time travel? What moral dilemmas would arise from our ability to change past events? Each scenario we envision compels us to explore not only technological advancements but also the essence of human nature. As we conclude this exploration into the physics of time travel, one question remains: if given the opportunity to explore time, would we shape our past, or would we choose to leave it untouched? Time is a complex and intricate tapestry, full of mysteries waiting to be unraveled. Let's continue our journey through time and delve into its impact on energy and resource consumption. When we think of time, we often imagine a linear progression, a river flowing from the past through the present and into the future. But what if I told you that the very nature of time, at its most fundamental level, is far more complex and perplexing than we can imagine? Welcome to the strange world of quantum mechanics, where time behaves in ways that challenge our deepest intuitions. Quantum theory suggests that particles exist simultaneously in multiple states until they are observed, a concept known as superposition. This leads to questions that resonate through the halls of modern physics. Is time itself a construct of our perception, a tool we use to make sense of events happening in a chaotic universe? In quantum mechanics, the concept of time behaves differently than in classical physics. At the quantum level, time is not a constant, it can stretch and bend. Consider the phenomenon known as quantum entanglement, where particles instantaneously affect each other's state, regardless of the distance separating them. This challenges our conventional understanding of time and space. For instance, take the famous thought experiment known as Schrödinger's cat, where a cat in a box is simultaneously alive and dead until observed. This scenario pushes us to ponder: does time exist in the same way for the cat, trapped in a state of uncertainty, as it does for us, observing its fate? The implications of quantum mechanics on the concept of time are profound. Some theorists suggest that the past, present, and future could be interlinked in ways we cannot currently understand. Time may not flow the way we perceive it. Instead, the fabric of the universe might operate on a more complex system that transcends our linearity. One of the leading physicists in this field, Carlo Rovelli, proposes a model of time that is closely related to the physical processes of the universe, suggesting that time is not a fundamental entity but rather a result of our interactions with the world around us. As we delve deeper into the quantum realm, we encounter the concept of time as an emergent property rather than a foundational element of the cosmos. This idea is conveyed in Rovelli's book, The Order of Time, where he elaborates on how temporal events and space-time structures emerge from quantum processes. It's not just theoretical rhetoric. Recent experiments have shown that particles exhibit behavior that suggests time could loop or even reverse in certain conditions. In one groundbreaking experiment, physicists manipulated atoms in such a way that they perceived a reversal of time on a quantum level. Could this imply a hidden nature of time that allows for the manipulation of events? As we move forward, we are reminded that reality may be far stranger than we have ever imagined. The quest to understand the quantum mechanics of time invites us into a world that expands our consciousness and challenges us to rethink everything we know about our reality. Perhaps in the future, we will unlock secrets that tell us that time, as we know it, is not as fixed as we believe, but a flexible and manipulable element of the cosmos. Are we prepared for this brave new reality? Stay with us as we probe further into the implications of time on our understanding of the universe and ourselves. As we look to the stars, we realize that time is not just a human invention, it is woven into the very fabric of the universe. The movements of celestial bodies and cosmic phenomena shape the rhythm of time on a grand scale. From the swift spin of a neutron star to the slow drift of galaxies, time manifests in myriad ways throughout our cosmos. Consider pulsars, highly magnetized rotating neutron stars that emit beams of electromagnetic radiation. These cosmic lighthouses act as celestial clocks, spinning with incredible precision. One such pulsar, PSRJ 1730-2304, spins 162 times per second, giving astronomers a remarkable tool to measure time across the universe. By observing these pulsars, scientists can gain insights into gravitational waves and even the expansion of the universe itself. Moreover, black holes, those enigmatic celestial giants, warp our understanding of time in extreme ways. As matter approaches a black hole, it experiences time dilation, an effect so profound that to an outside observer, it appears as if time slows down for the object falling in. This phenomenon raises questions about the relationship between time and gravity. The event horizon of a black hole may act as a threshold, beyond which time behaves differently. When we talk about the universe's history, we also consider phenomena like cosmic microwave background radiation, remnants of the Big Bang. This ancient light, emitted about 380,000 years after the birth of our universe, allows us to peer back in time, providing a snapshot of the cosmos a mere few 100,000 years old. Meanwhile, the Hubble Space Telescope has given us a look back over billions of years, revealing how galaxies have evolved through time. As we gaze into deep space, we are not just looking at stars and galaxies, we are looking into the past, where time travel is possible in a sense. The light from distant galaxies shows us what the universe looked like when it was much younger, illustrating the dynamic nature of cosmic time. Moreover, consider the life cycles of stars, from massive giants that burn bright and end in supernova explosions to smaller stars that gradually cool down, creating white dwarfs. Each moment in a star's life is a measurement of time, echoing throughout the cosmos long after the star has gone. As we contemplate the universe, we must acknowledge that it operates on a cosmic clock, a timepiece built from the interactions of gravitational forces, radiation, and the birth and death of stars. This interrelationship of events across vast distances invites us to think not just about time as a linear progression but as a multi-layered adventure that is intricately connected to the evolution of the cosmos itself. As we venture into the future, we may find ways to use these cosmic clocks to navigate the mysteries of existence and gain deeper insights into our place in the universe. What more might we uncover as we continue to explore time and its cosmic dance with space? In our next chapter, we will delve deeper into how these cosmic events influence our understanding of time on Earth, linking the celestial with the terrestrial. In an age defined by rapid technological advancements, our relationship with time is more critical than ever. With every innovation, from mechanical clocks to digital devices, our perception and management of time are constantly being reshaped. The invention of the mechanical clock in the 14th century marked a pivotal moment in history. No longer reliant on the sun or moon for timekeeping, humanity gained the ability to segment the day into precise hours and minutes. This shift was revolutionary, enabling people to synchronize their activities far beyond what was possible before. Imagine a world where the passage of time was dictated by nature. The clock allowed for a new form of organization, ushering in the age of industrialization. Fast forward to the present, where we live in a world dominated by smartphones and constant connectivity. Notifications ping with urgency, and our days are governed by the relentless march of time, measured in seconds. The impact of this technology is profound. Research has shown that the modern pace of life can lead to heightened levels of stress and anxiety. A study conducted by the American Psychological Association revealed that 44% of adults feel more stressed about their time management than they did a decade ago. Is technology enhancing our lives or shackling us to the clock? Consider the phenomenon of time poverty, the feeling that we do not have enough time to achieve everything we want. In a 2016 survey, 44% of respondents reported feeling this way regularly. This indicates a collective struggle with time, exacerbated by technology's promises of convenience that often lead us into chaotic lifestyles. Moreover, technology influences not only how we perceive time but how we experience it. The advent of social media has shifted our engagement with time, creating what experts term as a time distortion effect. The instant gratification of likes and shares can make real-life interactions feel sluggish by comparison. We often find ourselves caught in a race against time, constantly chasing deadlines, and living in a world of perpetual urgency. This can lead to a disconnection from the present moment. As we hyper-focus on efficiency, are we losing touch with the value of experiences? Look at the way we manage our schedules. Time-blocking apps, reminders, and every minute optimized for productivity can make life feel mechanized. In response to this overwhelming pressure, many people are turning toward mindfulness practices, attempting to reclaim the essence of time as a qualitative experience rather than a mere quantity. Techniques such as meditation and deep breathing exercises aim to ground individuals, bringing them back to the present while counteracting the fast-paced lifestyle. But what does the future hold? As we embrace future innovations such as artificial intelligence and automation, will we gain more free time or become further entangled in the web of technology? One potential avenue is the rise of the 4-day workweek, a concept gaining traction in various countries. Initial studies suggest that a shorter workweek can lead to increased productivity and job satisfaction, allowing individuals more time for leisure and personal pursuits. As we unravel the complexities of time in a technological age, we face a fundamental question: how can we harmonize our advancements with a deeper understanding of time's true value? The answer may lie in how we choose to navigate our moments, embracing a balanced approach that allows technology to serve rather than dictate our lives. Up next, we will explore how cultural interpretations of time shape our daily lives and interactions with others, revealing a tapestry of perspectives that influence our understanding of this elusive phenomenon. Memory plays a crucial role in our understanding and perception of time. It acts as a bridge between the past and the present, allowing us to make sense of our experiences and how they influence our actions. Have you ever wondered why some moments feel like they linger while others fade almost instantly? The answer is rooted in the intricate way our brains process temporal information. When we recall an event, our minds do not simply replay a video. Instead, we reconstruct memories based on sensory inputs, emotions, and various other factors. Research suggests that our emotional state during an event can significantly impact how we remember it. For instance, joyous moments may seem longer because they evoke positive feelings, whereas traumatic experiences may be marked by a disjointed perception of time. Consider the phenomenon known as the reminiscence bump, where people tend to have a richer recall of memories from their adolescence and early adulthood. This bump in memory could be linked to the formation of a person's identity and significant life events that shape who they are. But it doesn't just stop there. Different cultures can also shape how people recall and relate to time. In cultures with a linear perception of time, such as in many Western societies, people often view their lives as a timeline with distinct milestones. In contrast, cultures that perceive time cyclically, like some indigenous cultures, may emphasize the continuity of experiences and lessons. The implications of these differing views can be profound. For instance, in a cyclical culture, the past isn't just a series of events but a living part of the present. The nature of memory not only shapes our perception of time but also affects our decision-making. Cognitive psychologists have explored how our recollections influence our future choices. For example, decisions based on past experiences can be affected by how vividly we remember those experiences. A negative experience may lead to avoidance in a similar situation, demonstrating how the past continues to inform our present. Furthermore, as we age, our relationship with time can change significantly. For older adults, the perception of time often accelerates, creating a sense that life is fleeting. Some researchers suggest that this perception can be tied to the decreasing frequency of novel experiences as we age. Thus, engaging in new activities can help counteract this feeling, suggesting that both memory and time perception can be manipulated through intentional experiences. Ultimately, our experiences are intertwined with time and memory, shaping how we live in the present. The study of time, therefore, goes beyond physics. It dives deep into the essence of our consciousness, identity, and the very nature of our existence. As we progress through life, the memories we create not only influence our understanding of past events but also impels us forward into the future. With this understanding, one might wonder, how do we harness the power of memory to enrich our perception of time? Throughout history, humanity has sought to measure and understand time with greater precision. From the earliest sundials to today's atomic clocks, our quest for accurate timekeeping reflects our evolving relationship with this enigmatic dimension. But how did we arrive at the sophisticated technology we have today? Let's take a journey through timekeeping technologies that transformed not only our understanding of time but also our daily lives. In ancient civilizations, time was typically measured by natural phenomena, daylight, lunar phases, and seasonal changes. The Egyptians, for instance, used sundials and water clocks to segment their days. However, these methods were inherently imprecise, often affected by latitude and climatic conditions. This led to the creation of more sophisticated devices, such as the mechanical clocks that emerged in medieval Europe. The advent of the mechanical clock in the 14th century marked a significant shift. These clocks utilized gears and weights to maintain a relatively consistent rhythm. As technological advances continued, the precision of timekeeping improved dramatically. The introduction of pendulum clocks in the 17th century by Christian Huygens revolutionized accuracy, achieving a precision of 1 second per day. However, as society began to depend more on precise timekeeping, especially for navigation, new technologies continued to emerge. The 18th century witnessed the development of marine chronometers, which allowed sailors to determine their longitude at sea with remarkable accuracy. This advancement was crucial for the age of exploration, thus facilitating global trade and communication. But what came next altered the fabric of timekeeping entirely. The 20th century introduced atomic clocks, a groundbreaking innovation that relies on the vibrations of atoms to measure time with unparalleled accuracy. These atomic clocks are so accurate that they would only lose 1 second over billions of years. This precision has profound implications, impacting technologies we use every day, from GPS systems to the synchronization of the internet. Our dependence on precise time has shaped modern society, allowing for instant communication, precise navigation, and efficient scheduling. Recently, researchers have even explored the possibility of quantum clocks, which could push the boundaries of precision even further.